Hello everyone. Today we will be starting with the lecture series on TensorFlow. So TensorFlow is basically the library which actually used for implementing various deep learning architectures. So in this particular lecture series, what we will do is we will actually introduce you with the fundamental concepts of using TensorFlow, like how it is used. And then after introducing these fundamental concepts, we will gradually go further down into deep level concepts of these TensorFlow, that how TensorFlows are used for, library is used for implementing various deep learning architectures. For example, CNN, then we have neural networks, then we have generative adversarial networks. So we will be implementing all these architectures using this TensorFlow library. And also we will be discussing some details and also we will be discussing some important aspects which are not covered so far in this particular channel, and what that is basically, implementing transfer learning and all those advanced concepts, that is how to use multiple GPUs together. So let's understand how TensorFlow is used as a library for implementing various deep learning architectures. So in order to start with this lecture series, what I will be doing is I will be discussing the basic concept first, and then we will gradually move ahead. So the very first thing that we see here is this particular import statement. What is this import statement doing? It is basically importing the TensorFlow as TF. So this is nothing but you are actually importing this particular package, and you are actually writing it as a short form as TF, so that you can reuse TensorFlow again and again when you are calling some functions which are inbuilt in this particular package. So we will be now calling TF as the short form for TensorFlow. The very first example that you observe here related to the TensorFlow operations is creating tensors. So as the name suggests, TensorFlow, we should know what tensors is actually. Tensors are nothing but they are just matrices only, but their names are, but it's renamed, or you can say its name is different when you are using it in TensorFlow. So if you are using a one-dimensional array, that is also called as tensor, and if you are using a single constant value is also called as a tensor, and if you are using a matrix, then also it is called as a tensor. So basically it's just a name which is used for addressing arrays, matrices, as well as single constants by a single name, which is tensors. So let's start creating what these tensors are. For example, now if you want to define a scalar tensor, what scalar tensor is? Scalar tensor is defined as tf.constant, and then in brackets you will write 5. So what it means is that, like in other programming languages also, when you are using constants, that constants are called as the constants, but here in this particular TensorFlow paradigm, what you will call them as is tensors. So it's also called as scalar tensor. So when you want to define the scalar tensor, you will define it as tf.constant, in brackets you will write it as 5. So now if you want to define a vector tensor, what you will do, you will actually create a one-dimensional vector, which is very easy, like this: 1, 2, 3, 4, and then you actually use tf.constant again, because you are creating a constant tensor. So what you will be doing is you will be actually calling this as a vector, and then you are using this particular one-dimensional array as a tf.constant tensor. What do you mean by tf.constant? By saying tf.constant means the value of this 5, when it is passed into this scalar, this value will not change. So the scalar value will remain 5, it will not change at all. We will see in the coming demos what kind of error comes when you define some other value to this scalar value. Similarly, for vectors also, when you are defining tf.constant for this one-dimensional array, if you change the value of this vector, let us say if you change the vector by 1, let us say 10, 3, 4. So if you change this vector with this value, then this particular code will throw an error. We will see what that error is as we move forward. But the idea is, when you are defining some variable, whether it's a scalar, vector, or a matrix, by a tf.constant, the value will remain same throughout and it will not change. Similarly, if you want to define a matrix, again you can do it very easily by using the ideas of NumPy. So if you know NumPy, you can actually define the matrix like this. So this is a 2 cross 2 matrix. So what you are doing is you are actually defining this as a constant matrix, and I am naming it as matrix here. So once you create these scalar, vector and matrices, though their names are different, they are all called as tensors. They are all called as tensors. And tensor is basically a generalized name for defining whether it's a scalar, vector or a matrix. And similarly, if you go for a 3D matrix, which can be defined easily like this. So if you know NumPy, you can actually create a 3D matrix, something like this. Now when you encapsulate in this particular tf.constant, then what happens is this 3D tensor is again a constant, and if you want to change any specific value of this 3D tensor, it will not change at all. So let's run these executions as we have discussed here. So let me run this here. So this is created. So now let me run this. So now you see here, this particular scalar which is defined over here is now a tensor. So the tensor is actually 5, and it's a constant. Similarly, if you see this particular vector tensor here, this one, it is given as 1, 2, 3, 4. So it's a it's a one-dimensional vector, and its size is 4 cross 1 rather. Then you have a tensor here, which is the matrix tensor. You can see now the matrix tensor is saved as 1, 2, 3, 4. Then you have a 3D tensor which is given over here, and its dimension is 2 cross 2 cross 2. By default, the data type is integer 32 here. I have not specified. So if you want to specify the size, if you want to specify the type, then you can easily do it by using d type is equal to, let us say, float 32. So if you run this command again, then you can see that this particular data type has become float 32. So by default it is integer 32. Okay, so now we have some operations that we can do on these constant tensors. As the name suggests, you can see over here, we have this constant is equal to tf.constant 5. We are defining a constant const 1 variable which is tf.constant 5. So it's having a value of 5. Then we have another one with the value of 6. Now what we are doing is we are actually adding the two. So in order to add these two, what we will do is we will add by using the tf.add command. So once you use this tf.add command, you will get the answer of the sum const, which is equal to this particular value. What will be the value? It will be 11. Here also, if you see this particular example here, I am defining the matrix 1 as 2, 3, 4, 5. And then we have another matrix which is of constant value 4. So if I add this, what will be the answer? Can anyone think of it? I will show you the results. So let me execute this first. So here you see, when I am using 5 and 6, and if I am using tf.add, which is the function which is inbuilt in the TensorFlow, then the answer will be 11. So you can see over here. What about this? When you have 2, 3, 4, 5, and if you are adding a constant here, what will happen is this constant will be broadcasted, and this 4 will be added to each and every element of this matrix, which is very important. You see what is happening exactly is, let me show you. So basically what is happening is you have this particular matrix here 2, 3, 4, 5, and when you are adding a constant to this which is 4, this 4 is actually added and it is broadcasted to all the elements of this matrix and they are added. So effectively what is happening is it is 2, 3, 4, 5, and then you have 4, 4, 4, 4. So you are adding this matrix to a matrix of this particular matrix. So this is the example of broadcasting. So let me check one more thing. Like if I want to basically add this constants without using TensorFlow command, let me see if we can do this. Const 1 plus const 2, and then let me print this. Let us see this. So you see here again, you can actually do this direct addition as well, because there is no need to use this particular tf.add command. But if you want to use, it will be, you know, it will be good, because somewhere or the other these particular additions and multiplications rather are highly optimized in the TensorFlow libraries, and in case if you are using these libraries, your executions will be fast. But as such, you can actually use you can directly add also without using the tf.add command also, as we have seen over here. See. Okay, another important thing that I wanted to point out here is the difference between the NumPy values and the TensorFlow tensors. So this is very important. So let us see, if I use import NumPy as NP, and then if I define a np.ones, like this is basically what you are doing here is you are actually creating a a matrix of all elements as 1, and the size of that is 3 cross 3, and then if you print this array, what will happen is, you all know, this is all the values will be all 1. Now if I want to change any specific value of this matrix, I can do it easily by using this assignment statement. Like if I want to change the 9th element of this particular array, which is 2 cross 2 indexed, and if I want to put that value as 0, what I will do is I can easily do that, and you can see here I have already changed the value of the last position element. But now let us say if I use a third variable mat3, which is a tensor actually, and the type of this tensor is constant, and the values of this particular constant tensor is 3, and its shape is 3 cross 3. So basically it's a matrix with all the elements as 3. So let me execute this. So if you have this particular type of tensor, if I want to now do the same operation here by changing the last element of this matrix by 0, what I will get is an error. So what this is trying to tell you is that if you are defining a tensor as a constant, it's very difficult to change the value of that constant. Once you have defined it, it is defined. But if you want to change the values of this tensors, then there are some other concepts which we use, which is called as variables. So basically in the next lecture we will discuss variables, and we will see how variables, once they are assigned a value, can be changed. But here if you are defining them as a constant, it will not be changed at all. It's a constant value whose value cannot be changed. Now if you see here, another operation that you can do over the tensors which are constant is given over here. So here you have a matrix 1 and matrix 2. It's a matrix which is defined. So here now what I am doing is I am using the matrix multiplication of matrix 1 and matrix 2. So now if I want to multiply these two matrices together, what I will get is this answer. So the idea is basically you can actually use for loops as well to do this multiplication, but the idea to use matmul operation here is to speed the operations of the matrix multiplication. That's why we are actually calling this tf.matmul library, which is already implemented in the TensorFlow package. Okay, so now after this matrix multiplication, which we have seen as an operation on the constant tensors, now the idea of the basic slicing on the 3D tensor. So this basically gives you an idea about how slicing of the tensors are done. Like if you want to, by saying slicing means if you want to select a specific row and print it, or if you want to specify if you want to select a specific column of a matrix and want to print it, or if you want to print the specific rows, like maybe 1 row or 2 row of a matrix, or maybe if you want to do a combination of columns and rows of a matrix and want to print them. So that is what the idea is about slicing. So you are actually taking a portion of the matrix or a vector or a 3D tensor and printing it. So that is the idea. So let me show you how it is done. So here example is, like, let us say if I am defining this tensor as tf.random.normal 345. So what it will do is it will actually create elements which are selected from the normal distribution. It will be random elements and random numbers, and the size of that matrix will be a 3 cross 4 cross 5. So it's a 3D tensor. So now what I'm doing is I'm actually printing this tensor, and then now what I'm doing is I am now slicing this 3D tensor, and what I'm doing is I am actually selecting the first two matrices of this 3-dimensional vector. So here you see the first index is written like this. So for example, let me explain you. So what basically this particular thing is telling you is, so when you are writing tensor, what it means. tensor double dot 2, what it means is you are actually, selecting the first two matrices of this 3D tensor. So 3D tensor is actually of size 3 cross 4 cross 5. So you have in the third dimension you have 3, and then in each of these dimensions you have the matrix of size 4 cross 5. So you have a 4 cross 5 matrix like this, and behind that you again have a 4 cross 5 matrix, and behind that again you have a 4 cross 5 matrix. So you have actually 3 matrices which are forming as a cube. So what you are doing is you are actually selecting the first one and the second one, and you are dropping the third one. So basically what happens is you have, in the 3D tensor you will have indexes. So first index corresponds to the batch, like you are using the first one or the second one or the third one. Then the second index corresponds to the rows, and the third index corresponds to the column of the specific matrix. So in this particular case, what is happening is you are actually selecting the first two batches of the matrix. So let me run this and show you. So you see here you are having a three-dimensional matrix, and it can be easily seen by this 3 starting brackets. So this actually gives you a clear idea about that you have three-dimensional vector. So first matrix is this one, second matrix is this one, and third matrix is this one. So now what is happening is basically you are actually selecting the first two matrices. So by saying first two matrices, this matrix and this matrix, this is the two matrices that you will be actually selecting. So that answer which you are getting over here is this. So you see the first two matrices are these first two matrices which are over here, and the other one which is over here is neglected. So this is the slicing operation. So let's see another slicing operation. So what exactly is happening over here is, again you have a three-dimensional vector of size 3 cross 4 cross 5, and now what you are doing is you are actually selecting all the three matrices. So here let me tell you again what is happening here. You are actually defining a 3 cross 4 cross 5 matrix. So that means what? That means you have a first matrix like this of size 4 cross 5, then you have a second matrix like this, again that same dimension of 4 cross 5, and then you have a third matrix which is at the back side like this, and this is of same dimension 4 cross 5. When you are writing this, as I told you in the earlier code, the first one which is saying double dot, that means you are actually selecting all the batches which are over here. So all the three matrices will be selected. What about this? In this what happens is, this is the start, then stop, and then the increment. So this way you are actually defining the inside this particular indexing. So it has 2 dots and then 2. That means you are starting with the first row, you are ending in the last row, and then you are selecting alternatively at the step of 2. What is happening here is you are actually selecting the going from first row till the last row. That is, you are going from 0 to 4, and then what is happening is you are going with a step of 2. So you are actually selecting the alternate rows of this particular tensor, and then columns you are selecting all of them. So now if you see this particular example here, when you print this particular tensor array, which is actually a three-dimensional array indicated by these 3 brackets, so what you see as the output? You see as output all the 3 matrices. Then this matrix will be there, this matrix will be there, this matrix will be there. But for the black one, you will have alternate rows selected. Like it will start from 0, then it will be then it will take second row, then it will take the 4th row. That is what this particular indexing is telling you. So now, as you know, you cannot go up to 4. So what will happen is you will go up to 1 step before that. So what will happen? It will generate the output of the second row, and the 0th row. So let us see what is the 0th row here. This 0th row is minus 1.30, and then the second row is this one, minus 0.25. Let us see whether these two elements are there or not. See, in the first matrix you have these two elements. Now we go for the second matrix. So here you see in the first range you have all dots, right? So we are actually taking the second matrix now, and in this second matrix also we will select the first row and the second row. Similarly, you can see over here as the answer minus 1.45 and 0.56. Now if I go for the third one, you will have 0.05, minus 0.05 and minus 0.28, which is actually minus 0.05 and minus 0.28. So you have, you know, all these values printed out. And now you see the third one, it says all the columns. So basically you will be actually you know, displaying all the columns of this one, all the columns of this, similarly all the columns of this one and this, and similarly all the columns of this one and this. So you can see your outputs are here. And if you want to go for a specific column selection, then what you will do is you will actually write the code like this: tensor underscore array, then all the rows you want, all the batches you want to print. These are all batches, means number of matrices that are there. You have 3 matrices, so all 3 are there. Then you are selecting the alternate rows, and if you want to again select the alternate columns, then you can write like this. So this is the idea. So let me run this particular piece of code and show it to you. The results I have already explained. You can see now the results of this particular slicing operation. And if I, let us say, make it 2 and run this command, then you will see the columns are also less, because now it is selecting after every 2, like first one, then the 0.67 and then 0.4789. You see here now you have only 3 columns. So this you can actually play around and check how it is done. Next we are having advanced slicing with combined techniques. So here I have already explained you, like, you know, if I want to print the you know, this will actually print from the second matrix, because you see here in the Python actually we start with 0. Here indexing is given by 1, so that means you are actually printing the batches or the number of matrices from second till third, and then here you are actually printing 2 rows, which are the middle rows, which is the first and the second row, because you have 4 rows here. And now what you are doing is you are actually indexing from 1 to 3. That means you are actually printing only 2 rows, which are the middle of the middle of this matrix, that is minus 1.37 and minus 0.42. that is what you will actually print. And then you are, this I have already explained you that, you know, you are actually selecting the 2 columns. You are selecting all the columns with the jump of 2. So this is the increment step. So let me run this, and you see here what I am doing is I am selecting only 2 matrices. These 2 matrices are actually these 2 matrices, this one and this one, and then I am jumping in the columns. So if I am jumping by 2 steps, you will get 3 columns. And I am jumping in rows also, and in rows I am actually moving from 1 to 2 only, because you see Python indexing starts from 0, so 0, 1, 2, 3, so it will move up to 2 only, so 0 to 1. So I will be getting these rows, only these rows here, this one and these 2. So basically in these 2 rows what I will be getting is I will be getting the alternate columns of these highlighted sections which I have shown you. So here you see in this you will get the alternate columns, not from this slide, sorry, this is the another array. This is the tensor array which we were looking at. So basically you will be getting the alternate columns of this and this. So you can see over here, so you are getting the alternate columns of this particular highlighted section here. And similarly for this also you will get the alternate columns of the highlighted section here. So this is the first one. In the second one is with the negative values. So what negative means is you are actually starting from back. So if in this particular piece of code, what we are doing is we are actually writing -2 and -3. So what exactly it is trying to say is that you know normal indexing starts from 0 to any value. Let us say here in this case you have 3, but the reverse indexing starts with -1, -2, -3, -4, -5. So if you have -1, so basically what it will do is it will actually capture the last row of this particular matrix, and if you write -2, then it will be actually the second last row of this matrix, and then if you have -3, it is the third last of this matrix. So when you are using this negative indexing, what is happening is when you are writing -2, and then you are doing what? Then you are actually putting it as dash, and then you have -3, and then you are putting it as dash. What it means is you are actually starting from the second last row, and you are printing the last 2 rows. Whereas in this case -3 means you are actually moving from the from the opposite side of this column, and then what is happening is in the -3rd position you have the column which is the -3rd column, and from there you will move towards the right, and you will print all the columns corresponding to that. So here if you see in this particular example, let me show you here. Let me execute this particular code. So now what happens is, by saying this particular first indexing is that means you are actually taking all the 3 matrices, and once you have all these 3 matrices, what you are doing is you are actually selecting the second last row, and you are printing the second last row and the last row. Here what you are doing, you are actually selecting the third last column, and you are printing from that third last column till the last column. So here you see in the first case, if this is the array, so all these 3 matrices will be printed because the first column is having double dots. In the second, what it is saying is I will be printing the second last row and the last row. So this is the second last row and the last row. So let us see whether these 2 elements are there in the output or not. So let us go here and see. No, this will not be there because what is happening is we are also going from from here, we are going from third column here. From third column, you see we have -3 this side. So -3 means you are actually from the third column you are going till the last column. So what is the third column? -1, -2, -3. So this is the third column, and from here you will be going to this and then this. So basically if you basically the intersection of all these indexes will be -1.077 this. So somewhere or the other you will get this answer. From -1.07 -0.98, then you have this, then you have this, and then you have this, and then you have this. So these 9 elements will be there. 6 elements will be there. So let us see whether they are here or not. See, these 6 elements are there, and they are actually these elements. This one, this one, this one, this one, this one, and this one. Similarly, for the other ones, you will have 0.48, 1.39, 0.23, 1.38, -0.14, 1.4, and 0.24. See, so all these are here. So this basically shows you that you can actually use negative indexing also. Here, -2 means you are actually from the back side or from the lower row. You are actually the second last row you are taking, and you are moving towards the last row. Here you are taking the third last column, and you are moving towards the last column, and you are here selecting all the matrices. So this finishes off with the idea of slicing, and then we have already discussed some other concepts like various operations that we have, like for example matrix multiplication. Then we have seen the difference between the Numpy and TensorFlow tensors, and we have seen various operations also onto the constants, that is addition or multiplication, whatever it is. And then we have also seen how we define the tensors. Thank you so much for watching my lecture. In the next lecture we will go further details into this. Thank you.